So we left off looking at, we paused here, reactivity. So how reactive are elements? The further down and the further out you move, the more reactive you get. So find where K is. First of all, what is K on the periodic table? What element is that? Potassium. Is that more reactive or less reactive than lithium? What was the answer? Okay, so potassium is more reactive than lithium. We're actually trying to exploit that. Right now we make lithium-ion lithium batteries. We're trying to see if we can use sodium or potassium. In theory, there's more energy there, but they're also way more unstable. You might recall about 4 years ago, Samsung had those Note phones where the batteries kept exploding. That would be a risk with sodium or potassium batteries, but if we could stabilize it, there's more energy there to play with. So we're working on that, but who knows? Magnesium is more or less reactive than sodium. So again, as you move out and down, so is magnesium inside sodium or outside sodium on your periodic table? Inside, so it's slightly less reactive than sodium. Sodium, if you drop it in water, it'll explode. Magnesium, if you drop it in water, not so much. S. Which element is S? Sulfur is more or less reactive than chlorine. So is sulfur more or less reactive than chlorine? Well, because it's inside, it's going to be less. The rule is as you move down and out, they're more reactive. Okay? Let's talk about families. Columns of elements on the periodic table have similar properties, and some have names that you need to know. Does anybody know what we call the far left column? The one that starts out with hydrogen and then lithium? Yeah. And we have to be careful because one is called alkali and one is called alkaline. So these ones are called alkali. Do you need to memorize that, or is it on your table? I can't remember. Is it on the table? Okay. So that means as far as I'm concerned, it's fair game for me in a question on a quiz or a test or in the homework to say, to just talk or refer to the alkali metals, and I'll clue in, I'll expect you to clue in. I know which column that is. Okay? They're very reactive. They're very soft. Typically, you can squash them with your fingers, even though they're a metal. Let's blow some up. Put your pencils down, look. Family number 2, the blank earth metals, the second column from the left. Yes? And you're going to hear me, just so I'm clear, I'll say alkaline, and I'll really emphasize the N, because if I'm talking fast and I say alkaline, it's hard for you to tell, did he say alkali or alkaline? And so I will try and emphasize it, or I'll just say column 2, which is a little clearer. So alkaline with an N, alkaline, earth metals, little less reactive than the alkali metals, and that means they're a little safer. We can do more with them. One of the properties that alkaline with an N metals have is when they burn in air, they give bright colors, and in fact, they're used to make fireworks. Yep.
Would they also be used for like flares? Like when you're watching like
I don't think so, because the flare, you're not concerned about the color. There, you're concerned about the brightness. You want it to be as bright as possible. I think with flares, it's... Oh, no, I'm going to take that back. I was going to say it's going to be magnesium, which is the second one down. Magnesium, when you light it, it burns brighter than a camera flash, but for a long time, like to the point where it's not quite as bright as when you're welding something, but it's bright enough that I would say don't stare at it for very long because it's going to hurt your eyes. Okay? So put your pencils down. Moving on. What's the 17th column? 17th column is second from the right. What's that one called? Halogens. That's the 17th column. These are very reactive. Very reactive. Put your pencils down.
Oh god, there's more.
Noble gases, I forgot to hit record again. Very non-reactive, but not completely non-reactive. Short video. Put your pencils down. Pick your pencils up. Pick your pencils up. There you go. Thank you. Pause for 1 second. Rows, and the fancy word for rows is the periods. Those are the ones that go across. They go periodic periods. They go across the periodic table. So the periods go this way, and the families or groups go vertically. They go up and down. So can you find BR on your periodic table? Come in. Is there somebody at the door? Let me just pause the video for a second. Hold on. So can you find BR on your periodic table? Okay, what period number is it in? Count down. It's in period number 1, 2, 3, 4, 5, or 6. Which one? Period 3. And what row number is it in? Count over from the left. Or count backwards from the right. Row 17. And what family is it in? Halogen. Pardon me? You don't have that on the paper?
Yeah.
I forgot to include it then. Helium is in period number 1. Row number 18. And family? No. If you understood what we just did you understand how we found all that? Okay, if not, I'll bring it up. I didn't include that in your notes, that last two. If you want to add that, you can. Or if you understood how we found those numbers, that's really what we're worried about here. That's really what we're looking at. Question for you. Does anybody here have pencil crayons on them?
I do.
A couple of you? So I'm going to say on Tuesday, if you can remember to bring some pencil crayons, and I'll try and shoot an email out and remind you, because we are going to do a little coloring next class.
I love coloring.
Okay? But for now, what is your homework? So I handed part of it out last day. That was the section 2.1 homework. Sorry, section 2.2 homework, where I said that you could do this first page. But now that I've talked about the families, you should be able to do these pages as well. And then again, check your answers when you're done. I'm going to give you about 15 minutes to work on this, and then we're going to move on to another lesson.